Alright, welcome back to the class. Now we will talk about faults. What are faults? What are different type of faults? How do rocks move around fault plane? So this is an example of brittle deformation, where the rock actually breaks and moves, unlike the ductile deformation, where the rock was only changing its shape. It was not breaking into different pieces. But when we are talking about faults, we are talking about brittle deformation. So it will happen near the surface of Earth, because remember, brittle deformation occurs near the surface of Earth, and ductile deformation occurs much deeper in the crust of the Earth. So now let's go dive into the detail about faults. Faults are fractures in the crust with appreciable displacement. Movement parallel to dip or dip-slip faults. So there are a couple of these terms here: hanging wall block, foot wall blocks, fault escarps. So we will learn about these terms using some schematic, some figure here. So here this is one example. Here you can see these are the two different rock blocks, and this line here, this white broken line which is shown here, this is like a fault line along which you will observe appreciable movement or displacement of this rock. So the rock mass which is below this fault line is called as a footwall block, and the rock mass which is above the fault line is called as a hanging wall block. So these are the two walls which have broken, or the rock formed after the breaking apart, and this is the line along which the deformation has occurred. So remember, this line is called as a fault line, but this whole plane is called as a fault plane. And the rock mass below the fault plane is footwall block, and the one above the fault plane is a hanging wall block. And the reason it is called like this, because it's from the old days when miners used to dig through these rocks, they would stand on the footwall block, as it is shown here in the figure, and they will put their lantern or hang their lantern on the hanging wall. So this is how these two names came, footwall block and hanging wall block. And now we will see that how we can classify fault based on in which direction these walls move. So one more thing before we go any forward is the dip. That is a dip slip, right? So this angle over which the wall or the fault line is inclined, it is called as a dip, right? So this angle, because this wall can move either this way or this way. So I will show you with a figure here. So this is the same schematic I have drawn here. So this hanging wall or foot wall, they can move in this direction, right? Or they can move horizontally in this direction, right? So these are the two possible movement. One is like this, horizontally in this direction. One is like this, vertically in this direction, right? The orientation is not exactly perpendicular. The fault line is not exactly perpendicular to the ground. It has some angle here. So this hanging wall or foot wall will slide either vertically or horizontally. So this vertical plane of motion or movement is called as dip. Okay. So this one is called dip, this vertical plane along which the wall can move, and this one is called a strike. So you have two different planes or directions in which the wall can move along this fault plane. So this whole line together, it is called as fault plane, and the wall can or the hanging wall can move vertically or horizontally. When it is vertically, it is called as a dip slip, and when it is horizontally, it is called as a strike slip. Okay, so just remember these two terms, dip slip and Now the dip slip can be 2 or 3 different types depending on in which direction hanging wall moves. So there is a normal fault where hanging wall moves down relative to the foot wall. Right? So here if you look at this hanging wall has slid or as sliding downwards compared to relative to the foot wall, and that leaves you this little small mountain or hill region, and this one will make a basin here, right? So this one will become your depression like a basin, and this one will become your hill or mountain depending on how high it is. And this motion, this movement of these walls could be few meters or could be hundreds of meters, right? And also this fault plane can stretch few meters or hundreds of miles, like in the case of San Andreas Falls. If you look at this fault plane, it is hundreds of miles wide. So that is very variable, this length or extent of this fault plane. Fault block mountains are associated with large normal faults. So when you have large normal faults, these hills can be very high, and then you can call them as mountains depending on how much this hanging wall has moved downwards. So that will give you a much higher hill or mountains here, and then you will have a much deeper basin as well. So those are the terms here. Uplifted blocks are elevated topography called horst and grabens. So there is a more example here, much clearer schematic, and this normal fault occurs in the case of tensile forces, when these two rock masses are pulled apart in opposite direction. So this is tensile forces, these two rock masses are pulled apart, and that is what gives you a normal fault topography or normal fault geological feature. So this is graben, this is this basin structure is called graben, and the horst is your elevated topography, which is like a hill or mountain. So when you have these multiple fault lines, and if you have a tensile forces acting, you have these multiple horst and graben structure that will form here. Reverse fault is opposite of normal fault. In this case you have compressional force. So right now what I am showing here is this one. You have tensile forces and hanging wall is sliding downwards. In the opposite case, when you have a compressional force instead of tensile force, you can even have a compressional force, right? This one you can imagine a convergent boundary, like where in the case of Pacific Ocean continent, where oceanic plate is converging downwards, that is your compressional force. Another example is when the two continents are colliding, that is another case of convergent bonding. So it is a strong compressional forces, and that will lead to this hanging wall actually going up. It is riding up on the foot wall, it is not sliding downwards. So in that case you will call it a reverse fault, right? Reverse faults with a dip of less than 45 degrees. So thrust fault, it is an extreme case of reverse fault. It is a type of reverse fault, but if you look at here, this angle, right? So angle at which, if it is more than 45 degrees, then it is just a reverse fault. But if it will become more steep, then we will call it as a thrust fault. So reverse faults is when hanging wall is actually moving upwards instead of coming downward, which is in the case of normal fault. And when this angle of this dip, the fault plane, the inclination of the fault plane, it is very small, it's like hanging wall is almost riding over the foot wall, then it will be called as a thrust fault. And that is the case in the case of convergent boundary, like I was talking about ocean and continents, where you have a subduction zone, and the it looks like the continent. So those extreme cases of convergent boundaries where you have a subduction zone and oceanic plate is subducting under the continental plate, that is one example where you will see the thrust fault, where the angle of inclination of this dip plane is very small. It's almost like the continental plate is riding over the oceanic plate. And another example is when two continents are colliding, another case of convergent plate boundaries. So in the case of Himalayan mountain, where the Indian subcontinent plate is hitting against the Eurasian plate, and there also you will see that a case where the Indian continental plate that is riding over the Eurasian plate. So those are the examples, couple of examples that you will see as a thrust faults, where the dip angle is less than 45 degree, and it will almost look like the hanging wall is riding over the foot wall. Strike slip fault, it exhibits horizontal displacement. Like I said, there are two planes or direction in which the plate can move. One is vertical, another is horizontal, and the horizontal plane is called a strike plane, or it is also called as a strike slip fault. So you have dip slip and a strike slip. It is parallel to strike. So here are schematics that normal fault, when the hanging wall is sliding downwards, it happens in the case of tensional stress. Reverse fault, it occurs in the case of compressional stress, and the hanging wall is actually riding upwards over the foot wall. Thrust fault is a extreme case of reverse fault, where the hanging wall is riding over the foot wall and the angle of dip is smaller than 45 degrees. Strike slip, it is more like a shear stress, where the two plates are just sliding against each other in horizontal direction. So these are the four different kinds of fault. What is the relative motion on normal, reverse and strike slip faults? I want you guys to remember this. This may be in your exam. Hanging wall block down relative to foot wall block is equal to normal fault. So in the case of normal fault, hanging wall, it slides downward. In the case of reverse fault, hanging wall rides upwards. And in the reverse fault occurs when there is a compressional force is applied. Normal fault occurs when there is a tensional force is applied. Horizontal displacement is in the case of a strike slip fault.